Today we're going to be solving problems in the coordinate plane. As we work through the lesson, I want you to think about how you can solve problems on a coordinate plane. As always, we need to start out with our learning objective or our lesson objective for today, and it's I am learning to solve problems on the coordinate plane. I would encourage you as you go through this video that you take notes so that you can use them on your lesson work to help you out. Let's get the idea. A point can be flipped over a line. The new point is called a reflection. So it's like we're looking in the mirror, we see our reflection. So it's called a reflection of the original point. When a point is reflected across the x-axis or both axes on a coordinate plane, the signs of one or both coordinates will change. The new point also will be in a different quadrant. So let's look at the example 1 and see if we can understand what it's saying there. So for example 1, you're going to plot point A at a -2, 4 on the coordinate plane. Then you're going to plot point B at a -2, -4. I want you to compare the coordinates and the locations of point B and A. I've left some blank coordinate planes there for you, so you need to get those and use them as you work through the PowerPoint as well. Your strategy is going to be to plot points A and B on the coordinate plane and then compare the coordinates and describe how one point is a reflection of the other. So what I want you to do now is pause the video and try it on your own first. Again, you're going to work this out on a coordinate grid, so you may want to get one of those from up front. Okay, so let's look at the steps that we're going to take. The first step that we're going to take is we're going to plot points A at a -2, 4. Remember the x value goes first, so we're going to go to a -2 on the horizontal line, and then we're going to hop up 4 on the vertical line. And then we're going to plot point B at a -2, -4. Now, here we're just comparing these two ordered pairs based on what we see on the coordinate plane. So let's compare what we see. Both ordered pairs have the same x coordinate, so both of them have a -2. That didn't change for us here. The y coordinate of the ordered pairs are 4 and -4, and they have different signs. So when we hopped over that x-axis, the y value changed. So when you go across the x-axis, the y value is the one that's going to be changing. So let's describe the locations of the points. Both points lie on the same vertical line. X is equal to a -2. Point A is in quadrant 2 and is 4 units above the x-axis. Point B is in quadrant 3 and is 4 units below the x-axis. So point B is a reflection of point A over the x-axis. If you folded the grid paper along the x-axis, point A would fold onto point B, so it would be a reflection of point B. So our solution for this particular problem would be the coordinate plane above shows points A and B, and the points are reflections of each other across the x-axis, and their y coordinates have different signs. So let's get the idea here. The statements below show the relationship between reflected points and the signs of their coordinates. So if a point xy is reflected across the x-axis, the signs of its y-coordinate changes. So as you could see, if we went from x, y, if we reflect over the x-axis, x stays the same, but y becomes negative. If a point xy is reflected across the y-axis, the sign of its x-coordinate changes. So xy, if we reflect over the y-axis, it's going to be -xy. If a point xy is reflected over both axes, the signs of both of the coordinates change. So if I had xy and I went over the y-axis and then over the x-axis, my coordinates would both become negatives. So there's something that we can use that we learned earlier, and it's called absolute value. We can use absolute value to find the distance between 2 points on the coordinate plane. Now remember, absolute value is the distance from 0. So each axis on the coordinate plane is a number line. And since we know that absolute value is a number's distance from 0, we can use that absolute value to find the horizontal and vertical distance on any coordinate plane. So let's try example 2. A map of some important places in Carr County is shown on the coordinate plane. What is the distance in kilometers between City Hall and the library? So the strategy I want you to use is absolute value to find the distance between the points. Then use the scale to find the distance in kilometers. So you're going to look at the scale down here because sometimes that scale may be different. But if you look at this little H here, that's representing each one of these little marks here. So as you hop, those are considered 1 kilometer. I want you to pause the video and try it on your own first, and then we will go into the explanation. Pause your video now, please. All right, the first step that you should take is to identify the ordered pair. So City Hall is located at -6 and 3. The library is at 4, 3. So we want to use absolute value to find the distance from City Hall to the y-axis. And then you're going to use absolute value to find the distance from the public library to the y-axis. And then you're going to add the absolute values to find the total distance. So the solution here is the distance between City Hall and the library is 10 kilometers. If we look here, we're going to start here on the y-axis because that's going to be considered 0 for us. And if you hop over to a -6, the distance from 0 to a -6 is 6. So absolute value would be 6 here. And then we're going to hop over here from 0, and we're going to go over to 4, so the absolute value of 4 is 4, and then we're going to just add those two together. 6 plus 4 is 10 to get our solution for that. So the distance between City Hall and the library is 10 kilometers. We can also use absolute value to find the perimeter of a figure on the coordinate plane. So that's where we're going to go next. We're going to see what we can do with absolute value in finding perimeter. A rectangular garden is shown below. What is the perimeter of the garden? So the strategy I want you to use is absolute value to find the length of one vertical side and then one horizontal side, and then find the perimeter. Pause the video and try it on your own first. All right, so for step 1, we're going to use absolute value to find the length of the vertical line. So if I'm looking at the vertical line, I'm going to see here that my point is at a -6 for y. So the absolute value of a -6 is 6. And then I'm going to start here, and it goes up 6 units. So it's going to be the absolute value of 6, which is 6. So here I have 12 total on this side. Now remember to look at that scale. The scale is telling me 1 yard. Sometimes it may be in 2 yards or 3 yards. Remember, number lines can go up by different values, so you've got to find the pattern there. And then we're going to go up here to the horizontal line that's going across here. And if I start at the y-axis, I can see that it's 3 units to the right, which is going to be a +3, so the absolute value of a +3 is 3. Here we have a -5, and the absolute value of a -5 is 5. So when we add these two together, we have 8. So we have 8 by 12. To find the perimeter, we're going to need to multiply 8 times 2 and 12 times 2, and then get our answer. So find the perimeter, and there's multiple ways to do that. You could just add 8 plus 8 plus 12 plus 12 as well. So I'm going to leave that option up to you. So once you do all of your calculations, you should determine that the perimeter of the garden is 40 yards. Remember to use absolute value on these so that you can calculate it. You can also count the spaces, but remember you have to be very careful that you don't count where you start, but you do count where you're in. So if I'm starting here to count, I'm going to count as a hop. 1, 2, 3, 4, 5, 6, 7, 8. So I still came up with the same value. I'm going to let you choose which one you use, but it works better if you can solve it using absolute value. All right, let's revisit our learning objective to make sure that we know what we were supposed to have learned from this lesson. I'm learning to solve problems on the coordinate plane. What I want you to do is make sure that you keep those notes to use during any lesson work that I assign to you. And I hope you enjoyed the lesson. Thank you.